This is a recording for AQA Discrete Mathematics, Graphs and Networks, section 4.3, where we're considering the idea of isomorphic graphs. We say that two graphs are isomorphic, in other words exactly the same, if they have the one-to-one relationship between the vertices. They should have the same number of vertices and these should be the same order. The same number of edges, and those edges should be joining corresponding vertices. So that's quite important. It's not just a case of the total numbers, but that they are exactly the same in terms of their connections. We've already considered some isomorphic graphs. Here's two representations of K4, and we can see the corresponding connections between those. What about these three graphs? It's a case really of just checking the order of the vertices. So we can see in this one here we've got a vertex of order 2, 3, 4, 5 at the top. Sorry, I beg your pardon, of 6. This one here is 1, and then we've got 3 and 2. If we check this one here, then this one is 5, and then 2, 2, and 3. So obviously those are not isomorphic. However, we can check the final one and see, yes, this is exactly the same as the first one. It's got order 6, 1, 2, and 3. But not only that, the connections are exactly the same. Another way is to look at an adjacency matrix. Now it's easy to work out the order of the vertices from the matrix. You simply need to add up the numbers in the rows. So the first row there is 2, the second one 3, then 3, 2, 4, and 2. So we can see therefore that we must have 2 nodes order 3, 3 order 2, and 1 4. Well, that means that it rules out the first one, and we can see here's our node of order 4 in the second one. We've then got 2, 2, and 2, so 3 of order 2 and 2 of order 3. And we could also check the connections between those and that they correspond with the adjacency matrix. So when you want to prove an isomorphism, then what you need to do is to make sure that you get the corresponding vertices highlighted and connected together. So for example, if this one was labelled A, B, C, and D, and then the other one was L, M, N, and O, then we can see that A and L are the nodes of order 6. So A corresponds to L, B and N are the corresponding order 3 nodes, C and M are the order 2, and then order 1, D and O. So this is the mapping of the vertices in the first graph to those in the second graph, showing the isomorphism. That's the end of this video looking at isomorphisms. In the next few videos we'll be considering one aspect of graphs, which is to look at problems involving flows through a network.